because now we will discuss the numericals. Okay, so let us start the numericals. All of you take pen and paper. You take calculator also with you, because you need to find out, you need to use your calculator. Then you open the PDF which I have shared with you today morning, and also IS 456. Also IS 456, you open that. And now we will start solving the numericals. Okay, so let us start this. Okay, you can see the PDF. Can you see the screen? All of you? All of you, can you see my screen? Solved examples. I hope all of you can see the screen.
Yes, sir.
Okay, okay. So let us see the first numerical. I told you in the last class that moment of resistance is a very important part, and in exam you will get at least 2 questions on moment of resistance. Okay, so let us start the numericals. Okay, so in this numerical, you can read the question. Find the depth of neutral axis and percentage of steel for a balanced section of a singly reinforced beam using M20 and plain mild steel bar, and the second case is M20 and Fe415 bars. Okay, so we have to find out depth of neutral axis and percentage of steel for a balanced section. In this question you can see it is directly mentioned, it is our section is a balanced section. Okay, so this is a very easy numerical, very simple numerical. So since the grade of concrete is given M20, so we have to go to table number 21 of IS code, IS 456. You have to go to table number IS 456 for M20 grade of concrete. For M20 grade of concrete, this is the value of sigma CBC, 7 Newton per millimeter square. Okay. Okay. So, and one thing I want to tell you, if you appear, I don't know whether it is possible or not, if this time your final exam will be offline. Okay, if it is possible, if it become possible that in December or in November your exam will be offline, so in that case you have to write down everything. Okay, so whenever I am in my class, at least in my class, in my design class, whenever I will show you these numericals, all of you please write down. Okay, try to solve in the class only. Okay, so that whenever you have some doubt, you can ask me during the class only, so it will be easy for you to understand. Okay, after class also you can ask me, but it will be better if you ask during the class only. Okay, so now, okay, so let us go to the let us discuss the example again. So since in this question M20 grade of concrete is given, so sigma CBC value will be 7 Newton per millimeter square. This I have told you before also. And your mild steel bar is given. So mild steel bar means you have to understand Fe250. Okay. So if mild steel bar is given, then we have to find out our sigma ST. So can you tell me which value we have to take? This is our mild steel bar. We have 2 values. One is 140, one is 130. So can you tell me which value we will use? 130 or 140?
140.
Hello? Which value we will use? 130 or 140?
140.
Okay, we will use 140 because if we use more than 20 mm diameter bar, then it will be mentioned in question. Okay. Otherwise, we have to use 140. Okay, so let us see the problem now. Okay, you can see here. From table number 21, you have got the value of sigma CBC 7, and from table number 22, you have got the value of sigma ST, which is 140. Okay. So now we have the formula for M. M means your modular ratio. M equal to 280 divided by 3 sigma CBC. Put the value of sigma CBC here. It will be 13.33. Okay. Next, for balance section, see in this question it is mentioned directly, balance section, this one, it is balance section. So for a balance section, k equal to, I have shown you the formula, k equal to, k equal to this formula, 280 divided by 3 divided by 280 by 3 plus sigma st. So if you divide the value, if you divide 280 by 3, you will get 93.33. Okay, you will get this value 93.33 divided by 93.33 plus sigma st. Sigma st value is 140. Okay, so this way you can find out the value of k. So now depth of neutral axis. So since it is a balance section, very simple formula is there for finding out your neutral axis depth. N equal to k into d. Okay, n means your depth of neutral axis, kd. This formula, okay, this formula, n equal to kd. This formula we have to use for balance section, n equal to kd, nc equal to kd. Okay, we have to use this formula, nc is equal to kd. So now k value is known. We have already calculated the value of k. So put the value of k here. You will get n equal to 0.42. Okay. So this will be the answer. Okay. So this will be the value of depth of neutral axis. Because in this question, see, nothing is given. D value is not known. It is not given in the question. So our answer will remain like this. N equal to 0.4 times of effective depth. Okay. So this will be our answer. Then another thing we have to find out, the percentage of steel. Okay, so for finding out percentage of steel, what we have to do, we have to find out the value of J, because in that equation we have to use the value of J. Okay, so we have a relation between J and K. In the last class I told you the relation, or you can see in the PDF, J equal to 1 minus K by 3. This is the PDF which I have shared with you today morning. This is the value of J. Okay, J equal to 1 by K by 3, 1 minus K by 3. Okay, so we know the value of K. Just put the value here, you will get the value of J. Okay, so this way we have calculated the value of J. So now therefore moment of resistance of balance section. Okay, so this M means your moment of resistance, B for balance. Okay, so we have the formula MB equal to RBD square. So you can write down R here also, RQ same. Okay, R or Q, it is the same meaning. You can write down here R also. This equation, which I have shared with you, this equation or this equation. MR equal to RBD square, where R is equal to half sigma CBC K into J. Similarly, here it is written Q, you can write down R also. Okay, so put the values here, you will get the value of Q. Okay, you will get the value of Q. BD square, again BD square will be there in this equation, because we don't know the value of B, we don't know the value of D. These are not given in the question. Okay, these are not given in the question. So our moment of resistance value will be this one, 1.214 BD square. This will be the value of moment of resistance. BD square will be like this only, because we don't know the value of B, we don't know the value of D. It is not given. Okay, so after getting the moment of resistance, next thing, let's see here. So percentage of steel formula is 50 K square divided by M into 1 minus K. Okay, this is the formula. This is the PDF of last class, but this PDF I have shared today morning only. I hope all of you have got this PDF. Okay, this is the percentage of steel formula. PT equal to 50 K square divided by M into 1 minus K. Okay, 1 minus K. So we have the value of K, we have the value of M. So just put the values in this equation, you will get the value of percentage of steel. See here, 50, K value is 0.4, M value was 13.33, 1 minus K. So after putting all the values, you have got PT equal to 1. 1 means 1%. Okay, that means in this case we are using 1% of steel. Okay, so now for the second case, I request everyone to solve the second case. I request everyone to solve the second case by yourself. Okay, all of you have the PDF with you. Don't see the PDF. Don't see the PDF. Try to solve it by yourself. And then you tell me the answer. All of you have the PDF. Don't see the PDF. Try to solve this question. For the second part. Everything will be same. Only one thing will be different. Can you tell me what will be the different thing for the second case? Can anyone tell me?
FE415 bar.
Yeah, Fe415 bars. So for this Fe415 bars, what value will be different? Which value will be different? Which value will be different?
T.
Hmm? Which value will be different for Fe415? Please don't see the PDF which I have shared with you. Please don't see the PDF because otherwise no need to solve it. Okay. I am asking you, you try it by yourself. Without going through the PDF, you try to solve it. Everything will be same, only one thing will be different. What is that? Arif Khan? What will be the different? What will be the
T.
different? What will be the
Sigma ST.
Yeah, how much will be it be? Now sigma st value will be how much? In the second case, what will be the value?
30.
In the second case. In the second case, what will be the value of sigma st? Huh? Please answer. Okay, please answer. Or at least write in the chat box. If I am asking something, at least so many students are present, but no one is.
T.
Students are present, but no one is.
230
How much it will
Newton
be?
per mm square. 30.
Yeah, 230. Okay, so now. Yeah, 230. Okay, so yeah. Now with this value, you try to solve this and find out the value of n, find out the value of j, find out the value of momentum resistance. Try to solve it. All of you, please try to solve it. Oh, design of source structure. टीचर को फॉर्मूला पढ़ने के लिए नहीं दिया तुम लोग को मेरे को बाकी सिस्टम का है हाँ होगा होगा जल्दी सितंबर में आ गया तो हाँ सितंबर में आके तो तुम्हें ये तो बोल रहा है पूरा सितंबर लास्ट में आ जाओ उस वाले पहले आ जाओ यही जाओ. Okay, did you get the answer? Those who didn't copy from the PDF, you respond. Please respond. If you copied from the PDF, oh, okay. What is the value of n you have got? What is the value of n for the second case? For the second case, what is the
D.
n?
Sir, 13.3.
How much?
29. 0.29.
0.29. Okay, 0. Okay, and what is the value of j? N value is 0.29d. Okay, what is the value of j? What is the value of j?
Sir, 0.9.
Yeah, 0.91. Yeah, 0.9, 0.9. Okay, 0.9. So next you find out moment of resistance. Moment of resistance by this formula. Find out moment of resistance by this formula. MB equal to RBD square or QBD square, whatever you write. Find out moment of resistance. How much is the value of moment of resistance?
0.9.
No. Oh, 0.9.
No,
0.9. Only 0.9. Moment.
0.9135.
0.9135.
Okay. And will it be something else? Only the value, or you have something else with value? Moment of resistance will be 0.91 BD square. BD square will be there. BD square will be there. Just like this in this case. BD square value will be there. 1 point, it will be 0.91, some 9135 or 91 BD square. 91 BD square. I think all of you have got this value, n equal to this one. J is this one. Moment of resistance is this one. Okay. So now you find out the percentage of steel. Find out the percentage of steel by this formula. Find out the percentage of steel by this formula. Did you get the answer?
6.48.
No. Percentage of steel by this formula. 50 k square divided by m into 1 minus k. I think something is wrong. You check it. Check your calculation again.
0.467.
How much it is? 0.
1.467.
0.46.
1 point
1 point.
467.
1.467. No, it is not correct.
0.44.
Yes, good. 0.44. 0.44. 0.44 will be the correct answer. See, 50 k square. K value is 0.289. M value was 13.33. K is this one. Then if you solve this one, you will get 0.44. All of you have got this answer? See the calculation? See the calculation?
Sir.
Okay. Now you see the numerical. See the next numerical, how they have done it. It will be better if you can write the question and try to solve it by yourself. At least first part. At least first part, you try to solve it. See the numerical, read the question. What we have to find out, read the question. Okay, see in this question, what is the difference between the previous question and this question? That in this question it is not mentioned whether what is the type of section, means whether it is balance section or under reinforced section or over reinforced section. Nothing is mentioned. But in the first question, it was directly mentioned that it is a balance section. See here, in this question it is directly mentioned it is a balance section. Okay, so before solving the numerical, you have understood that we have to use the equation for balance section. But in the second question, nothing is mentioned. What will be the type of section? So for this kind of problems, our first aim will be to find out what will be the type of section. Whether it will be an balance section or under reinforced section or over reinforced section, we have to find out first that one. Okay, and to find out that, there is only one way. We have to find out actual neutral axis value and critical neutral axis value, and after comparing the two values we can say whether it is a under reinforced section or balance section or over reinforced section. Okay, so if you remember, if you see the PDF which I have shared with you, or if you have make any note in the last class, this was the diagram for balance section. Balance section means, in balance section actual neutral axis and critical neutral axis become equal. Okay, both lie at the same point. Okay, but for under reinforced section, you can see our actual neutral axis will shift upwards. So in that case, n value, that means actual neutral axis value, will be less than critical neutral axis. See this condition. You have to remember this condition. Okay, without remembering this condition, you can't solve this problem. For under reinforced section, actual neutral axis depth will be always less than critical neutral axis. And for over reinforced section, actual neutral axis will be always more than critical neutral axis depth. This is the condition. So both the condition you have to remember. Okay, to find out moment of resistance, you have to remember this condition. Okay, so now let us see the problem. So now first aim is to find out the type of sections. Okay, so I told you how to find out NC, depth of critical neutral axis. We have to use this formula. I have shared the PDF with you today. In that PDF, the formula is given, this one. M into sigma CBC divided by sigma ST. This N is your critical neutral axis, NC, divided by D minus NC. So from this equation, you have to find out the value of NC. NC means depth of critical neutral axis. Okay, so see this. Okay, so we have got the value of NC as 144.13 millimeter. Okay, so next thing we have to find out the actual neutral axis depth. Okay, so for doing that we have to use another formula, this one. Okay, all of you have, I think all of you have got the PDF which I have shared with you today morning. In that PDF this formula is written, you can see that. Okay, we have to use this formula to find out this N. This N means depth of actual neutral axis. Okay, depth of actual neutral axis, B n square divided by 2 equal to M AST D minus N. Okay, so this is the formula. B value is given, width of the section is given 300 millimeter wide. This is the value of B. Then 500 millimeter effective depth, that means this is the value of small d. And AST, 3 bars of 16 mm diameter, that means area of 3 bars you have to find out. Okay, so AST will be 3 into pi by 4 d square. 3 into pi by 4 d square will be the area of steel, because we are using 3 bars and diameter, and area of 1 bar is pi by 4 d square. Okay, d is your 16, d means your diameter. So we have got the value of AST, then B and D. These values are given. Okay, so now if you put the value here in this equation and if you solve it with your calculator, you will get N equal to 139.13. Okay, so next thing we have to compare these two values. N means depth of actual neutral axis and depth of critical neutral axis. So in this case, we can see that our NC is more than N. That means depth of critical neutral axis is more than depth of actual neutral axis. So what is this condition? If this condition is satisfied, what will be the type of section? Whether it will be under reinforced, over reinforced, or balanced? What will be the type of section if N is less than NC? If N is less than NC, what will be the type of section? Under reinforced or over reinforced or balanced?
Reinforced.
Reinforced.
Under reinforced.
Reinforcement section.
It will be under reinforced or over reinforced? Hello? It will be under reinforced or over reinforced? Huh?
Under reinforced.
Reinforced.
Okay, so now we have to the conclusion that our section is an under reinforced section. So for under reinforced section, how to find out moment of resistance? Which formula we have to use to find out moment of resistance? Which formula we have to use to find out moment of resistance? For under-reinforced section? For under-reinforced section, we have to use this equation. Okay, this is the equation for under-reinforced section. So we have to use this equation. Okay, so in this equation you can see sigma st we have it is known, ast is known, d is known, n is known. N means actual neutral axis depth. Okay, so if you put all the values, you will get moment of resistance. See this? See the formula? Sigma st it is known, ast it is known, d is given in the question, n means depth of actual neutral axis 139.13. This one. Okay, so if you put all the values, you will get this huge value you will get. But what will be the unit? This will be in Newton and millimeter, because if you see all the values, sigma st value, what is the unit of sigma st? It is in Newton per millimeter square, area is in millimeter square, d is in millimeter, n is in millimeter. So whatever value you will get here, it will be in terms of Newton and millimeter. Okay, but if you want to convert this value in terms of kilonewton and meter, we have to divide this whole value by 10 to the power 6, because from Newton to kilonewton you have to divide it by 1000, and from millimeter to meter again you have to divide it by 1000. That means you have to, if you divide the value by 10 to the power 6, then your answer will be in terms of kilonewton and meter. So see this, if you divide by 10 to the power 6, then your decimal will be shifted by 6 places to the left. So 1 2 3 4 5 6, so 62.95. okay, 62.95, it is the your moment of resistance. Okay, so I hope all of you have understood this problem. Yes or no? If you have any doubt in this problem, you can ask me now. If you have any doubt in this problem, you can ask me now. Otherwise, I will tell you to solve the next one. If you have understood this problem, I will tell you to find out to solve the next numerical. Okay, wait, I will explain it again. Okay, first read the question. Read the question first. So it is, our final aim will be to find out the moment of resistance. Okay, moment of resistance of a RCC beam 300 millimeter wide and 500 millimeter effective depth is reinforced with 3 bars of 16 mm diameter, M20 grade of concrete, and Fe 415 steel is used. Okay, so now since M20 grade of concrete is given, so from table number 21 of IS 456 you will get sigma CDC will be 7, and for Fe 415 you will get sigma ST equal to 230 from table number 22 of IS code. Okay, so next we have to find out the value of M. M formula is 280 divided by 3 sigma CBC. Sigma CBC value is 7, this one. If you put the value here, you will get the value of M. Then B is given. B means width of the beam is given, 300 millimeter, it is given in the question. D is also given. D means your effective depth, it is also given in the question. AST means area of steel. So in this question, it is mentioned that we are using 3 bars of 16 mm diameter. So we know that area of 1 bar is pi by 4 d square, because our bars are circular in section. So area of 1 bar is pi by 4 d square, and since we are using 3 bars, so multiplied by 3. Okay, so we have got the value of AST. Then we have to find out the value of critical neutral axis by this formula. Okay, this formula you will get in the PDF which I have shared with you today morning. Okay, and you have to remember this formula. Okay, so this M is known, this is 13.33, sigma CBC is 7, sigma ST is 230, NC is unknown, D value is 500. So after putting all the values, you will get depth of critical neutral axis is 144.13. So next we have to find out actual neutral axis. Okay, so for actual neutral axis we have to use this formula. Okay, we have to use this formula, bn squared by 2 equal to m into ast into d minus m. B is the width of the beam, which is your 300. N value we have to find out. M is 13.33, this one. Then ast is known, 603, this one ast. Then d is known, it is given in the question. N is unknown. So if you solve this question, if you still solve this equation in your calculator, you will get n equal to 139.13. Okay, so now if you compare these two values, nc and n, you can see that actual neutral axis depth is less than critical neutral axis depth. So this is the condition for an under reinforced section. Okay, critical neutral axis is below. This is the condition for an under reinforced section. See here, it is in condition for under reinforced, and hence the moment of resistance of the beam will be calculated by this formula. Okay, so Arif Khan asked that, do we need to learn the values of table 21 and 22? No, no need to learn the values, because in exam also you can use this IS code. Okay, in exam also you can use IS code, no need to remember the value, but you have to know how to use this table. Okay, you have to know how to use this table to find out sigma st, sigma cbc and other values. Okay, that one you have to know, but no need to remember any value. Okay, no need to remember any value. In exam you can use IS code also. Okay, so now Rupasri, I think you can understand this problem. I think you have understood this problem.
Sir.
বুঝি পাইছা নে Rupasri?
Palu, sir.
ঠিক আছে দিয়া. Okay, so now
Yes.
let's see the next problem. Okay, so all of you try to solve the next one. Exactly same problem, but it is simple, then it is easier than the previous one, because in this case m value is directly given, sigma st and sigma cbc. What values are given?
हो जाओ
Hello?
बाप हो जाओ
Huh? Please mute yourself. Tengya, please mute yourself.
आता वो एक गाड़ी पार्किंग में ही आता है ना emergency ATM मान को हमारो ये मालो गाड़ी हो तुम तो गाड़ी साथ अब ATM आधा घंटा दया है तो पूरा बहुत सारा जाम पास पूरा
Vengya,
सत्तर बन वो ना जाम मतलब वो लास्ट फुल अधिक से ATM काने ना कोई ये गाड़ी का एकदम गलती जाती है
Try to understand this problem. Everything is same with the previous one. In this case, directly M is given 13.33. No need to find out. This 7, that means it is the value of sigma CBC and sigma ST, both are given. Okay, so we need to find out the moment of resistance. Exactly same with the previous problem. So I hope all of you can solve it. These are the values given. Then we have to find out NC by this formula. Then actual neutral axis by this formula. Then we have to compare the values. If you compare the values, 159 and 166 is your actual neutral axis and critical neutral axis is 159. Okay, so that means your actual neutral axis is less than critical neutral axis. So this is the condition for an over-reinforced section. See, this is the condition of over-reinforced section. So for over-reinforced beam, this is the formula to find out moment of resistance. Okay, this is the formula to find out moment of resistance. If you put all the values, you will get the value of moment of resistance. Exactly same with the previous one, but in the previous one you have got it is an under reinforced section, but in this case you have got it is over reinforced. Okay. Okay, so I have given you the attendance. Okay, no need to worry for that. All of you have got the attendance. So our class will be over. Our class will be over by now. Okay. So please go through the things which we have discussed today. And if you have any doubt, you can ask me tomorrow again. Okay. In tomorrow's class, if you have any doubt, you can ask me again.